Welcome back to our science class. Today we are going to learn about a new chapter. Let us start with the chapter measurement and motion. Yes children, now let us learn about the mind map. The chapter is about measurement and motion. So first about measurement. What do you mean by measurement? A process of comparing unknown quantity with a known fixed quantity. Mean to say, we used to buy vegetables, oil, milk, grocery, so many, is it not? So when we buy some amount of vegetables, it will be unknown. So how to measure that unknown? We are measuring this unknown quantity with a known fixed quantity. That's what said to be as measurement. Clear children? Yes. Now this measurement is again classified into two types. For measuring the substances, that is classified into two types, that is standard units of measurement and traditional units of measurement. So in ancient days they used to measure all the substances, all the things by some way. We are going to learn about that. First about hand span. First thing is about hand span. Second thing is cubit. And third is yard. And fourth is foot. Okay, so we learn about all the ancient methods in detail. And then about standard units of measurement. Nowadays we are using the standard units of measurement which is internationally acceptable, that is meter, kilogram, second, Kelvin. Okay, and so many are there. We are going to learn about each and everything in detail. And then about motion. The second part of this chapter is about motion. So what do you mean by motion? An object that changes its position with time and surroundings. In short, motion is the movement of the object. Okay, so there are different types of motion said to be as translatory, circular, rotational, oscillatory, vibratory, periodic, non-periodic and random. So we are going to learn about each and everything in detail. Yes children, now let us start with a new topic, that is measurement and motion. Okay, so in our daily routine we buy several things like vegetable, oil, milk, cloth, etc. So when we are buying, for that we have to measure length, mass, temperature and so many. So first we want to understand about measurement. What do you mean by the word measurement? Measurement is the process of comparing unknown quantity of an object to be measured with known fixed quantity of same kind. So one hand we are having unknown quantity and in other hand we are having known fixed quantity. Okay, say for example, we might buy 5 kg of vegetable, is it not? So how much ever that is unknown, and in other side to buy that unknown amount quantity of vegetable, on one side we are having known fixed weight, is it not? That's the way we are buying, is it not? Yes. So I repeat, measurement is the process of comparing unknown quantity of an object to be measured with known fixed quantity of same kind. Okay, then the known fixed quantity which is used in the measurement is said to be as unit. The known fixed quantity which is used in the measurement is said to be as unit. Clear children? Yes. Then the measured quantity is always expressed as number which is followed by unit. What is this? For example, 5 kg. 5 into 1 kg. 5 into 1 kg. Is it not? Yes. Now this 5 number, this number is nothing but the number of times the unit contained in the measured quantity. So if we have taken 5 kg, it denotes that 5 times the unit measurement is there. 5 times the 1 kg measurement is there. Is it not? Yes. So the number of times the unit contained in the measured quantity is the number 5 or any x. Okay. And then quantity. Quantity is the second half. Is it not? Yes. Quantity is the numerical. Quantity is nothing but the entire, that is numerical value into unit, that is 5 into 1 kg. Unit is 1 kg and the number is the number of times the unit present in the unknown measured quantity. Okay, and then quantity is nothing but the numerical value into unit. So any quantity that can be measured, any quantity that can be measured is said to be as physical quantity. Physical quantity. For example, length, mass, time, temperature and volume. All these are examples of physical quantity. Clear, children? Yes. Then to specify physical quantity, we need magnitude and fixed unit. Two things. What are they? Magnitude and fixed unit. What is this? For example, length is expressed as 5 kilometer. The distance is measured as 5 kilometer. Is it not? Where this 5, number 5 represents magnitude and kilometer represents unit. So on the whole, this 5 kilometer is magnitude into unit. It needs magnitude and fixed unit. So physical quantity, length, anything is represented by two things, that is magnitude and fixed length. Magnitude is, for example, 5 and fixed length is fixed unit. Fixed unit is kilometer. Clear? So that's what. Then the physical quantity that are unique and cannot be expressed in terms of anything else. So that is unique to their own thing. So in that way, that physical quantity is said to be as fundamental physical quantity. What are they? Fundamental physical quantity. For example, mass, length, time and temperature. Okay. So this is what about basics of measurement. Now let us continue with the traditional way of measurement. In which way they are using? They are not having modern devices, is it not? But still they used to measure exactly and accurately. So how they will measure on that day? That we are going to learn. In ancient times, people use different parts of their body, such as arms, hands, feet as units. These are all used as measuring units earlier. Okay, for measuring the length. The distance between the end of an outstretched arm, and the tip of the nose. From the tip of the nose to the outstretched arm till here, the distance is meant to be as yard. What is this? Yard. Clear? Yes, children. Now, further, the length from elbow to the tip of the middle finger. What is this? The length from elbow till the tip of the middle finger here to here. Okay, it's said to be as cubit. What is this? Cubit. C-U-B-I-T. Okay, then a foot was also a common unit of measuring length. Okay, then next thing is about hand span. What is this hand span? A hand span is the length between the tip of the thumb and the little finger. Okay, so tip of the thumb from here to here, the little finger. This distance is said to be as hand span. Clear? Yes. So hand span is the length between the tip of the thumb and the little finger of our stretched palm. Clear? Yes. Next thing is about standard unit of measurement. So till now we learned about different ancient methods what they are using for measuring. Next thing is about standard unit of measurement. Okay, so to overcome the inconsistencies of measurement, mean to say this foot and the hand span, all those value will change from person to person, is it not? It's not a common thing. So to overcome the inconsistencies of measurement, standard unit of measurement come into existence. So for an example, if I'm saying 1 kg, it should be 1 kg universally. It should be 1 kg universally. It should be universally acceptable. So in that way, they have brought this standard units. Okay. So, and uniformity adopted an internationally acceptable system of standard unit of general conference of weight and measurement. So they taking mainly as weight and measurement into consideration, and they have brought this common, that is standard system of units. So let us learn about standard units. So this SI stands for System International Unites. System International Unites. So this is, they have mentioned in French. It's what system? SYSTEME. Okay, International Unites. Then, so we are going to learn about now the standard units. So they are classified into 3 ways, that is fundamental quantity, then standard unit of system, and then unit symbol. Unit symbol is a single letter which denotes this fundamental quantity. Okay, so let us learn one by one, that is length. So first, length, the standard unit is meter. Length is measured in meter, and here it's denoted by a single letter m. It's denoted by single letter m. Clear, children? Yes. Now mass. Okay, mass. Here mass is represented by standard quantity, standard unit kilogram, which is denoted by kg. And then time is measured with a standard quantity, standard unit second, and it's denoted by letter S. Clear? So these are some standard units. Then some other systems of standard units are also there. Apart from this, some other system is also there. For example, CGS. First type is CGS. The C stands for centimeter. Centimeter for length. They are using the centimeter for measuring the length. Then kg for mass. They are using K for measuring the kg, for measuring the mass. And then second they are using to measure the time. So totally C, G from kg, C, G, S. That's what the CGS system. Clear? Yes. Next type is MGS. What is this MGS? MGS stands for meter, and then kg, G, and then S second. Okay, so meter is measured for length. Is it not 100 meters? Like that we used to measure the length. Then kg for mass. Kg, 5 kg, 10 kg we are measuring for mass, weight. Then second for time. 60 seconds make 1 minute. Like that, seconds we are using to measure the time. Okay, so that's what in short mentioned to be as MGS. Clear? Yes. Next thing, next type is FRS. FRS. What is this? Foot for length. Foot for length. Pound for mass. Pound for mass. And second for time. And second for time. So these are different systems, that is CGS, MGS and FRS. They are also used occasionally. Clear? Yes. Next thing is unit of length. Now they are using some specific unit to measure the length. What are the units? Kilometer. That is in short represented as km. So 1 kilometer is equal to 1000 meter. 1 kilometer is equal to 1000 meter. Then decimeter, which is represented in short as dm. So 10 decimeter is equal to 1 meter. Is equal to 1 meter. Then centimeter, in short it's represented as cm. So 100 centimeter makes 1 meter. 100 centimeter makes 1 meter. Then millimeter, which is in short represented by millimeter. Okay, so 1000 millimeter makes 1 meter. 1000 millimeter makes 1 meter. So these are different units of length. Next, unit of mass. Unit of mass. So what are they? Kilogram. Kilogram, that is kg. In short represented as kg. So 1 kg is equal to 1000 grams. 1 kg is equal to 1000 grams. Next thing is quintal. Quintal. 1 quintal is equal to 100 kg. How many? 100 kg. And then milligram. Milligram. 1000 milligram makes 1 gram. 1000 milligram is equal to 1 gram. Clear, children? Yes, children. Now let us learn about units of time. Okay, so minute, MIN. It is represented in short as MIN. So 1 minute is equal to 60 seconds. 60 seconds. Then R in short is represented by H. So 1 hour is equal to 60 minutes. Then day in short is represented by D. So 1 D is equal to 24 hours. 1 day makes 24 hours. 24 hours makes 1 day. Okay. Then year in short represented as Y. Okay. So 1 year is equal to 365 days. 365 days. So these are different standard units of measurement. Then a variety of instruments are available to measure a quantity. For example, a tailor cannot use a meter rod for taking measurements of a person. Is it not? Yes. A tailor cannot use a meter rod for measuring any person. So they are providing different instruments for measuring each and everything. Then for that we are going to learn about what are the different available things to measure the length. Measuring length. Length is a measure of a distance between 2 points. Generally length is nothing but a measure which is a distance between 2 points. Then measurement of length involves measuring the length, thickness, width, height and distance. So in between 2 points, that measuring length, it denotes that we are measuring length, thickness, width, height and distance. So there are several instruments for measurement like scale, meter rod, measuring tape and others. Okay. So now a scale or a ruler. A ruler is used to measure small length. Generally we are using the scale or ruler to measure the small length. It has markings like meter, millimeter on one side. Where meter and millimeter on one side, meter and millimeter on one side, and inches on the other side, and inches on the other side. Then a meter rod. What is this? A meter rod. So who will use this? Generally tailors will use this meter rod. Meter rod is used to measure slightly bigger length. So measuring the length of the fabric, tailors generally use this meter rod. It has a fixed length of 1 meter. So the meter rod has fixed length of 1 meter. So generally cloth merchant use meter rods to measure the length of the cloth. To measure the length of the cloth. Clear children? Yes. Next thing is about measuring tape. What is this? Measuring tape. A measuring tape is used to measure longer lengths. Is used to measure longer lengths. They are used to measure length, breadth, length and breadth of a room, and then length of field. So to measure the long distance, we are using here measuring tape. We are using measuring tape. So we are going to learn about each and every instrument, how they are using, how they are applying to measure the length. Clear? Yes children. Now you can see a scale here. Is it not? Yes. You all might have been noticed several times. This is a scale which has in both the sides some readings. So what is this? You can see here 1, 2, 3, 4, 5. Is it not? So these are bigger divisions. And then here if you notice, small lines are there. Smaller divisions is also there. Is it not? Yes. So what is this big division? What is this small division? The big number of divisions, that is 1, 2, 3, 4, they have written now. Yes, that is centimeter. That is centimeter. So this scale has totally 30 centimeter. And then the small divisions, you can see from 0 to 1, you can see 10 lines. Is it not? The small lines. Small number of divisions represent millimeter. What is that? Millimeter. So 1 centimeter is equal to 10 millimeter. 1 centimeter is equal to 10 millimeter, or in other words 1 millimeter is equal to 0.1 centimeter. What is that? 0.1 centimeter. Then here you can notice I kept here an object, that is a pencil. Is it not? So now one end of the object coincide with 0 mark. Okay, and then the other end represent a specific marking. Is it not? Yes. So if you are noticing the reading corresponding to the another end of the object, it is here 15.2. After 15, 2 more small readings. So that is 2 millimeter mark after 15. 2 millimeter mark after 15. So totally this object size is 15 centimeter plus 2 millimeter, that is 15.2 centimeter. That is 15.2 centimeter. So this is how we used to measure an object with a scale. Clear children? Yes children. Now the next point is about, while measuring, our eye should be vertically above the point. How it should be? Vertically above the point at which the measurement is being taken. So if I am marking this 10 from different angle, it might result in an error. That type of error from different angle if I am marking, that type of error is said to be as parallax error. It's said to be as parallax error. So always remember children, while we are measuring, our eye should be vertically above the point. It should be vertically above the point. Yes children, now we are going to measure the irregular shape object. So I kept here one tube, okay, which is an irregular shape object. So this object, it's difficult to measure by a ruler or a meter rod. So that's why we are using here a thread to measure the irregular shape object. So how to measure? Beginning of the curved line will be pressed by thumb. Can you see this? Yes, the beginning of the curved line will be pressed by thumb. Then I have traced a small length of line with a thread. Then press the other end of this traced thread with a finger of the other hand, that is till here and again till here. Okay, so till here we have marked, then it should be extended like this. The thing that we have marked till there, and then you should extend. So you should proceed like this till the end of the irregular shape object, and this is how you are measuring using a thread. Yes children, now you can see this. What is this? This is a divider which will be there in your compass box. Okay, so you're going to use this divider to measure the length. How it is used? Place one tip of the divider at the beginning of the curved line. Then place another tip of the divider on the curved line. Put a mark at this point. So till here you have to mark, and then you want to continue moving the pair of dividers till the end of the curved line. So you have to rotate like this till the end of the curved line, and then at the end you want to count all the markings. So first marking you have to measure the length, and the rest you can calculate from this. So this method is said to be as divider method to measure the length. Clear children? Yes children. Now let us learn about estimation. So what do you mean by estimation? The ability to guess the amount of anything without actual measurement is said to be as estimation. An approximate value is said to be as estimation. Approximate value of quantity is said to be as estimation. So for example, if you are planning for a trip, we gather the estimates of distance, time and cost. Is it not? Yes. So this is what about estimation. Yes children, now let us learn about motion. That is the second part of the chapter. So what do you mean by this motion? An object that changes its position with time relative to its surroundings is said to be in motion. I repeat, an object that changes its position with time relative to its surroundings is said to be in motion. For example, when you are kicking a ball, the ball is in motion. That is, it is moving. Is it not? Yes. So that ball position is in motion. Then an object that does not change its place or position with time relative to its surroundings is said to be as stationary or rest. So when the object does not change its position, then it's said to be as stationary or rest motion. Okay, so for example, when you kick a ball, the field will be at rest. The ground will be at rest. Is it not? The position of ground will not change. So that is one example for stationary or rest. Okay, next thing. In short, motion is nothing but the movement. Motion is nothing but the movement. Then rest and motion are relative terms. Both the things are relative terms. Say for an example, if you are traveling by a car or a bus, when you are traveling, you might see a pedestrian who's standing outside. So for him, in the pedestrian point of view, you are moving. You are in a moving state. Is it not? So you are just in a motion. And then, but for you, he is standing outside. He is in rest or stationary mode. Is it not? So both this motion and rest, both the things are relative terms. Then next thing is about the different kinds of motion. There are different kinds of motion. So we are going to learn about those different types. So the first type is translatory motion. What is that? Translatory motion. So then the motion in which all the parts of the body or object move through equal distance in same direction and time. Move through the equal distance in the same direction and time, then that is said to be as translatory motion. For example, when a bus or a car or a train moves along a straight line, of course all the parts of the bus is also moving along with that. Is it not? All the parts of a bus or a car or a train move in the same direction. All together is moving in the same direction. Is it not? Yes. And then it cover equal distance in a given interval of time. Equal distance in a given interval of time. So this is what's said to be as translatory motion. Now further, this translatory motion is divided into two types. What are those two types? Rectilinear and curvilinear. What is that? Rectilinear and curvilinear. So what do you mean by this rectilinear? When a body moves along a straight line, it is said to be as linear or rectilinear motion. I repeat, when a body moves along a straight line, then it is said to be as linear or rectilinear. For example, a car moving along a straight road is one example for this rectilinear motion. Second type is curvilinear. What is this curvilinear? When a body moves along a curved path. When it is moving along a curved path, it's said to be as curvilinear motion. For example, moving a car on the curved road. When a car is moving on the curved road or in the hilly areas, you might get that hairpin bends and all. Is it not? Yes. So then that type of the movement is said to be as curvilinear motion. What is that? Curvilinear motion. Then next type is circular motion. You know, circle shape. Is it not? Now, when a body moves along a circular path, when it is moving along a circular path, it's said to be a circular motion. Here in this type of circular motion, the starting and end point will be the same position. Is it not? Starting and end point will be the same. That's what circular motion. Now, let us learn about the next type, that is rotational motion. Yes children, now let us learn about rotational motion. The motion of bicycle wheel, merry-go-round are examples for rotational motion. So when you are going through merry-go-round, the top seems to be moving around. Top will come down, down will go top. Is it not? Then it moves based on the center axis. That's what. The top seems to be moving around an axis passing through its center. Such a motion is said to be as rotational motion. The body moves about an axis. Is said to be as rotational motion. Clear children? Yes. Next thing is about oscillatory motion. oscillatory motion. Here, the motion of a swing. Example, the motion of a swing. The repeated to and fro motion of a body about a mean position is called oscillatory motion. Is called oscillatory motion. One complete cycle from the point of release to the other extreme and back to the initial point is said to be as one oscillation. What I said? One complete cycle from the point of release. When you are releasing that swing, one complete cycle from point of release to the other extreme and back to the initial point. So from where they started to that position again when it reaches, that is said to be as one oscillation. Clear? Yes. Next thing is about vibratory motion. What is that? Vibratory motion. So here the movement of a string of a guitar when it is plucked, the type of the motion in which a part of body develops fast to and fro about a mean position. Is said to be as vibratory motion. What I said? There is a fast to and fro about a mean position. Okay, fast to and fro about a mean position. Then next thing is about periodic motion. What is that? Periodic motion. So here any motion that repeats itself after a fixed interval of time. After a fixed interval of time is said to be as periodic motion. Say for an example, a clock, the second, minute, hour, once again I repeat, the second, minute, hour, hand of clock repeat their motion after every 1 minute, 1 hour and 12 hours respectively. Periodically it keeps on changing as such, is that not? So that's what it's said to be as periodic motion. Next thing is about non-periodic motion. What is that? Non-periodic motion. Any motion that does not repeat itself after a fixed interval of time. Fixed interval of time is said to be as non-periodic motion. For example, a cyclist who's moving in a straight road. He is doing the same action, but it is not repeatedly done. Is it not? Repeatedly done after 5 minutes. It's not like that. So that is one example for non-periodic motion. Clear? Yes. Next thing is about random motion. What is that? Random motion. So here when motion of the body is irregular. What is that? When the motion of the body is irregular and unpredictable. We don't know which side it will go. In that way if it is, then that type of the motion, that type of the movement is said to be as random motion. For example, flow of water in rivers, then flight path of an insect. Flight path of an insect. Clear, children? Yes, children. Now about random motion. So what is this random motion? When the motion of the body is irregular and unpredictable. Okay, we don't know where exactly, in which direction it will flow, in which direction it will fly and all. Those type of the movement comes in the random motion. Random motion. For example, flow of water in rivers and then flight path of an insect. What is that? Flight path of an insect. Okay, that's what about random motion. Yes, children. Now, in general, that is motion of hands of clock or watches show periodic as well as circular motion. Sometimes both the things is also applicable. Okay, like in sewing machine, wheel undergoes rotational motion, needle undergoes periodic motion. So in total, in the sewing machine, it undergoes both rotational and periodic motion. So it occurs like this also. Okay, so the next part of this chapter is about history of transportation. History of transportation. So what do you mean by the word transportation? Transportation is nothing but the movement of people or goods from one place to another. Goods from one place to another is said to be as transportation, either people or goods. Then, in early days, humans moved only by foot. Is it not? The very first time, they used to move only by foot, and then they carry their goods by themselves. Then, slowly, they use animals for covering long distances and for carrying goods. Is it not? Then they started to use animals. Then they observed round logs of wood move easily compared to flat objects. They found that round logs of wood move easily compared to flat objects. So this led to the invention of wheel. Okay. Then slowly development of carts pulled by animals like bullock carts. Okay. Bullock carts have been animals they are using for carts that could easily carry people, and heavy loads also they can carry over long distances. To cover long distances, they are using these type of carts which is pulled by animals. Then later they learn to build boats and ships. Then after that they learn to build boats and ships. That was the next step in their invention. Next, the invention of steam engine. What is that? The invention of steam engine was the next major breakthrough in the field of transportation. Then the steam engine has now been replaced by advanced and more efficient engines which is driven by diesel, petrol, gas and electricity. Is it not? In all the ways now car runs. Then another step in the history of transportation is the invention of aeroplane, okay, which is by Wright brothers. Then today several modes of transport, methods or modes of transport are available like cycle, bike, auto rickshaws, car, bus, train, aeroplane. Okay, like this so many modes of transport are available. Then so that we can choose a suitable mode of transport depending on distance to be traveled and the time and cost of travel. Clear, children? Yes. Yes, children. Now an activity for you all. That is, you want to measure the traditional units of length. Digit, span, foot, cubit, hand and fathom. Digit you know, span from here to here, okay, hand from here to here, okay, and then foot you know, cubit is from the middle finger till here, till the elbow, and then hand I said here to here, and then fathom is from the middle finger till here, the entire measuring. You can use your measuring tape to measure. Okay, so these are different measures. So you can see, refer to the page 166 in your textbook. Okay, and then measure in centimeter with a ruler or else with a measuring tape. Measure it for different people in your home or house and record in a table form. Clear? So submit and forward in your class email ID. So this is your activity. Yes, children, with this we have come to an end of this chapter. So after watching the video, read the chapter thoroughly so that you can understand well. So we'll meet in the next class. Thank you all.